In this video, we're going to look at another example of an improper integral that has both limits of integration going off to infinity. So we're being asked to determine whether the integral from minus infinity to infinity of x cubed e to the minus x to the fourth dx converges or diverges. So since we've got this doubly improper integral, if you will, we need to split it into two integrals at some intermediate point. 0 is probably the most convenient, so we'll split it at 0. So we'll have the integral from minus infinity to 0 of x cubed e to the minus x to the fourth dx, plus the integral from 0 to infinity of x cubed e to the minus x to the fourth dx. We'll replace both of those limits of infinite limits of integration with a variable, and let those variables go off to negative infinity and positive infinity respectively. Again, we want to call them different variable names because they don't have anything to do with each other. So I'll call the first one a b and let b go off to a negative infinity, and call the second one a c and let c go off to positive infinity. Now we're able to evaluate this antiderivative of x cubed e to the minus x to the fourth using the u substitution. If you let u equal negative x to the fourth, then your du would be a negative 4x cubed dx. So we'll need to adjust with a negative 1/4, and we're basically integrating e to the u, so we'll get an e to the u in its antiderivative. So the antiderivative we're going to use here is going to be a negative 1/4 e to the minus x to the fourth in both integrals. The first one will get evaluated from b to 0. The second one will get evaluated from 0 to c. Put in 0 for x, we'll get a negative 1/4. Put in a b for the x, we'll get a 1/4 e to the minus b over 4. As b goes to negative infinity, b to the fourth will go to positive infinity, and doing the opposite of that, so we're getting a big negative number in the exponent. So e to that will go to 0. So this will just go to negative 1/4 when we're done. Likewise, we'll put in c and put in 0, so we'll get a negative 1/4 e to the minus c to the fourth plus 1/4 for our second integral. As c goes to infinity, negative c to the fourth goes to minus infinity. So this term is going to go to 0, and we're going to go to positive 1/4. So we'll get 1/4 minus a fourth between the two of them, or 0 for our integral. So in this case, our integral converges to 0.